So good morning, friends. So as of now, we have completed HDFS, and I have given overview about Spark with Scala. And today we will continue Spark, but we'll have a overview about Python. So from the API's perspective, they don't change much. It is same whether you are using Scala or Python. Only thing is you need to understand the differences in syntax and semantics. Okay. And here I'll be primarily demonstrating using the CloudX Lab cluster. You can use your quick start VMs or Hortonworks sandboxes, anywhere you can practice this. So I'm logging to the CloudX Lab cluster. Okay, and for the reference purpose, you can go to my Big Data Engineer course. So this is the lesson, Apache Spark with Python. So these are the topics that will be covered, and you have to click on this link. Okay, if you click on this link, it will take you to the actual lesson, and these are the topics which you can learn by going through the material. Okay, whatever I have covered using Scala, similar things I have covered using Python on the same data set. I have done aggregations, I have done word count, everything. Okay, so for Python, what I will do is I will show how to get started, how to access the documentation, how to run word count program, and then directly we'll go get into sorting and ranking. We will do both global as well as by key sorting and ranking. In that process, we will also learn a little bit of Python. Okay. From the programming language perspective, Python and Scala is almost similar. Only thing is Scala runs in JVM in the form of bytecode, whereas Python runs as an interpreter. It's not a compiler-based programming language. It's interpreter-based programming language. Hence, so we should be able to execute the programs directly without compiling into the jar file. Typically, with respect to Python, we will directly submit the Python jobs without compiling into jar file. In case of Scala, it's always better practice to create a jar file, ship the jar file to the cluster, and run the jar file over there. Okay. So now let's get started. So when you set up Spark, it automatically comes with Pyspark. Pyspark stands for Python with Spark, and if it is integrated with Hadoop, the storage will be HDFS, and MapReduce engine will be execution framework will be Yarn if it is integrated with Hadoop and Yarn. Otherwise, as we have seen earlier, we can also run Pyspark programs either on local mode, Mesos, or standalone, or Yarn. All the modes are supported even with Python. From the execution perspective, only difference is here you will be running the Python script rather than a jar file on the cluster. Commands are a little bit different. Means you use Spark submit only, but the way you pass the arguments and all those things are a little bit different compared to Scala-based executing the Scala-based Spark programs. Okay, so now the Pyspark is launched, and here one major difference between Scala and Python is Scala, Python, as well as Java. We will start with Java. In Java, we have to define data types for each and every variable, each and every parameter to the function. You have to define a data type. Nothing will be resolved at the runtime. Okay, that is called a strong typing. So you have to define data types whenever you create the variables. Whereas in Scala, in most of the cases, it will be inherited. For example, if you launch Scala and if you say val I equal to 0, because 0 is of type integer, I will become integer data type automatically, and it will be evaluated at runtime. Whereas in Python, but in some cases you have to define the data types with respect to Scala, especially when you create the functions. The parameters should have data types in some cases. Otherwise, it will fail. Okay. Whereas in let me see, something is okay. So whereas in Python, everything is inherited at runtime. You don't need to define data types anywhere. Everything will be taken care automatically. And there is no way to define data types also in Python, as per my knowledge. I am also amateur in Python. I am not expert. So as per my knowledge, there is no way to define the data type. Okay. So to create a variable, you just have to give the variable name. For example, if you want to run the read the departments table, you have to say departments equal to. Now comes the Spark APIs. When we launch Pyspark as in Spark shell, it will create the Spark context object. You can see it here. Okay. So sc dot text file, and we have to give the path. As it is integrated with SDFS already, we don't need to give the name node URL, port number, etc. Just give the user training 8634, which is nothing but my home directory in HDFS, and then data retail underscore db slash departments, and hit enter. Okay. Now you can say departments dot count to get the number of records. I think I have to say print departments dot count. Still it is not doing. Let me see. And to print the records in it, you have to use for in. So we have to define for loop, and then departments dot collect. Either you can give the print of I in the same line, or you have to go to the next line. And here, when it comes to Python, like in Java or Scala, you don't define the scope using braces. Instead, you need to understand the relevance of indentation, and you have to use indentation for the scope. So for example, if I have to run something as part of the for loop, I have to indent within the for loop. And if the for loop is enclosed in some other if condition or while loop or another for loop, everything is determined by indentation. You will understand by the time we write some programs. So I am using two spaces as indentation, and you have to use the same pattern for everything. Once you start with 2 spaces or 4 spaces, you have to follow the same pattern for the for the indentation to define the scope. Now I am saying print of I and hit enter. Yeah, so data is coming. I don't know why the count does not work. Let me try. Probably I have to give brackets. Yes, I didn't give the brackets. That's why the count did not come. Now you can see that data is read successfully, and we can see the number of records in the table here. Okay, so this is how you can start with Python. And now we will see how to actually submit the jobs. Okay, for that I am using this as reference. I think I have the code snippet as part of the Python getting started. Yeah, so this is the code snippet. As we have seen in Spark, we have to create a conf object and then context object. Okay, for that we have to import, and this is how you typically import in Python. Okay, so now I am creating the Pyspark demo .py. That is the program name. And from Pyspark import Spark context and Spark conf will make it available to the will make context and configuration available uh, to the program. Okay, and then here we have to create conf object Spark conf dot set app name Spark Pyspark demo. Okay, and if you want to set the master to local or yarn, you can set it over here. Okay, let us try with yarn client as master, and then we have to create our context object. And it takes parameter, and we are only passing one parameter. I think there are more hidden methods. Hence, to make sure that we invoke the Spark context constructor with one parameter, we have to use this one. Conf is the name of the parameter which accepts as part of the Spark context constructor, and the local object name also we have created as conf only. Okay, and then we will actually try to read the data. Okay, this I have already explained. We just have to make sure that we use correct path, especially if you are practicing on CloudX Lab, which is shared by many people. You have to give your user space here, which is training 8634, and then data retail underscore db. Here also we have to say the same thing, training 8634. Yeah, let me use this one. Department testing under user training 8634. Sorry for the background noise. Okay, now the program is saved. The way you have to run it is you can use Spark submit like this: Spark submit -- master local save file.py, or Spark submit -- master yarn if you want to run it in yarn, and then you can give the file name. Okay, and the file name is Pyspark underscore demo.py, and hit enter. Again, if you want to set the parameters such as executor memory, executor course, etc., you can do that. And the same way we have done with the Scala, you can pass all those parameters. Only difference is in Scala, the command is same. You use Spark submit, and then you give the class name which says -- class. You give the class name, and then you pass all the other control arguments, and then you use the jar file at the end, and you give the parameters to the jar file. Whereas here we are doing in a different manner. Okay, if you want to parameterize, you can parameterize even in Pyspark, but I will not be covering it here. It will be very straightforward even to parameterize in Pyspark as well. So we have to do it in similar manner. Okay, now let us develop a word count program so that we understand how to use map, flat map, and reduce by key using a simple example. Okay, so especially if you are planning to give the certification, you have to go through the entire content both in Scala and Python. There is no shortcut. You have to know how to use Spark APIs as part of the programs they give. You don't need to write complete Scala Spark-based Spark applications, Scala Python-based Spark applications. especially with respect to CCA, they give the code snippet and also a shell script. Shell script will be having the Spark submit command. You don't need to worry about Spark submit command also, as per my knowledge. And then along with the shell script with Spark submit command, they also give a Scala program or Python program. You will have all the if conditions for loops, etc., whatever is required to write the logic, oral logic. But they will ask questions about how you create RDD, how to join the data sets, how to aggregate those things. One-liners in the middle of the script. Probably you might have to update 2 or 3 lines in the entire program. And once you validated the program using the terminal or command line interface, you have to update those code snippets in the script, and you have to run that script using the shell script which they have provided to you. You don't need to use Spark submit. You just have to invoke the shell script. Once the shell script is invoked, it will save the results wherever they have mentioned as part of the script, or where or they will ask you in the question, and you have to use the appropriate path, and your output will go to that path, and then they will evaluate those things, and they will give back the results to you. Okay, so it's very important to understand how the certification works. Certification is not primarily to test Scala or Python skills. It's primarily about to test Spark skills. So you should be proficient enough to use Spark APIs by using Scala or Python as programming language. Okay. So now let us see how we can do word count. As part of this, we will cover a little bit of Python, and then all the map, flat map, as well as reduce by key, how we can use those APIs as part of our Pyspark. Okay, so let me see if I have a text file here. There is word count.txt. So this is what we have. I just created some random text somehow. You can use whatever text you want. And then we have to save this file into HDFS. Probably I might already have this. User training 8634 word count.txt. Okay, file is already there, so we don't need to copy to HDFS. In your case, if you are trying to do it for the first time, you have to create the text file and copy it to HDFS. Okay, once copied to HDFS, we can start Pyspark here. Okay, and let's say lines is the RDD name, sc.text file, user training 8634 word count.txt. Only difference between Scala and Python is here we used to have val in Scala. Here we don't need to define whether it is val or var. Now the RDD is created, we can validate it by running lines.count. It is very important to validate it after each and every step until you get comfortable and you understand what is going on. So lines, so we are able to read the data without any issues. That means the path is correct. Okay. Now what we have to do is we have to say lines dot. We have to apply the map function. Here we will be using lambda functions or anonymous functions, whatever we have used earlier. So in Python, to create a lambda function, you have to say lambda. You have to use this keyword lambda, and then you have to give the parameter names. In this case, let's say parameter name is rec. Okay, and then you have to give colon. Whereas in Scala, you would have set this one, rec equal to greater than rec implies, and then you have to give the logic. Here we say lambda rec, and we have to end the specification of the lambda function with colon, and then we can say rec dot split space is the delimiter. So for word count we have to use flat map, not the map. Okay, now if you want to display what is in there, let me create a variable here, lines flat map equal to, and hit enter. Now you can say for, if you want to display what is in there, for I in lines flat map dot collect. It's always better to use take. In this case, I'm using collect, but generally you should use take to preview the data. Okay, and then print of I and hit enter. You can see the data is splitted and flattened out. Now we have to use map function to associate one with each of the words so that we can get the word count. Okay, if you are new, whoever is watching online in YouTube, or if someone lands here directly, to understand why we are using flat map and map, you have to go back to the Scala based videos which are covered earlier, and then you will understand the reason why we are using flat map, and now why we are going to use map. For all those who are in the class, I hope you guys remember what we have done with Scala. So it's continuation to that. So here what I'm saying is lines map equal to lines flat map, and we have to use the map function, and we have to give the lambda, we have to define the logic in the lambda function. In this case, we are creating a tuple. A tuple is represented in the same manner as it is in Scala. So in this case, we just have to say rec comma 1. Okay, and then hit enter, and then you can actually say lines map, for I in lines map dot collect print of I. Now you can see the strings are represented with U, which is nothing but Unicode. That's how the default print logic of Python works, and the value is 1 because for each and every word we have associated 1 with it. Now we will actually get the word count. So I'm creating word count as the variable name WC, and then lines map. Here we have to use reduce by key because we want to get count of each word. I hope you already remember the difference between aggregate by key, reduce by key, and group by key. In this case, reduce by key is the most appropriate one, so that for each word we can actually get the count. And here it takes two parameters, which is accumulator and value, and we have to add accumulator and value to get the word count. Okay, as I have explained to you earlier, for each key, depending upon the number of elements, this logic will be executed. Reduce by key function will be invoked once per key. Okay, but this logic, whatever is defined in the lambda function, will be invoked based on the number of elements that are present in each key. Okay, initially accumulator will be 0, val will be the first element, and then accumulator will be reset by adding value after each iteration. After all the values are completed for that key, you will get the final outcome, which is sum of all those values, which are nothing but sum of all ones for that key, which is nothing but the count of that word. Okay, and hit enter, and then you can say for I in WC dot collect print a file and hit enter. Now you can see the word count for each of the word. Okay, so this is how we can actually write the word count program. Let me revisit what all things we have done. First, we have read the file using sc.text file. Again, as part of the certification exam, they will give Sublime text, and you can open the files which the skeleton code in Sublime text, and better to modify over there. Okay. I will actually demonstrate. I'm planning to conduct how to be what needs to be done before going for the certification. What you can expect, and how you can use the environment in much better fashion, so that you don't worry about the so a lot of guys who give the certification, they are not well proficient with the Linux and Linux desktop. So I want to do a quick demo which will have some editors in it, and how to use the terminal and all those things down the line. But keep in mind that you can use the editors such as Sublime Text as part of the certification exam. It's better to use that one, Sublime Text or gedit, whatever is available. Okay. So in this case, so you can copy this line. First, we have read the file, and then we have used the flat map, so that the lines are split into words and flattened into the records. And then we have used the lines map, and then we have used reduce by key, flat map, and reduce by key. So you can actually, copy paste these 3 lines into Sublime Text. Okay, and then to see the result, we have used this for loop. Okay, either you can write it in single line or multiple lines with indentation. Okay, so this is the 5 lines code which you need to write to do the word count. If you think from the MapReduce perspective, it took a lot more lines. At least it took 20-30 lines to get the word count. Okay, the major difference again from between MapReduce and Spark based APIs is, in MapReduce you only get map function and reduce function. Rest of the stuff you have to take care by using map or reduce function. Whereas in Spark you have so many transformations for specialized purposes like join, reduce by key, aggregate by key, sort by key, etc. Hence, your development life cycle can be much better when it comes to Spark. Whether it is Python or Scala, the amount of coding effort is almost same. Okay, so that's about word count. Let me know if you have any questions, and then we will quickly move on to sorting and ranking using Pyspark. First, we'll see the global sorting and ranking, and then we will see by key sorting and ranking. So as part of this, we will understand few more APIs, but the implementation will be done in Spark. Already we have seen map, flat map, filter, reduce by key, aggregate by key, etc. as part of earlier classes. Now we are going to see few more transformations and actions using Python as programming language. Okay. So first let us understand the global sorting. Let's say you want to, so we have something called products dataset. So as part of our dataset, there is a products table. And let's say you want to get all the products in ascending order by product price, so that you know what is the highest product price in the end, or you might want to get it in the descending order. It could be either way. Okay, first we will see how to get the top to low prices or low to top prices out of products table, and then we will also see all the other information also. So you will understand as we go forward. So first let us read the products. It's under, I have already copied into HDFS, and it's under user training 8634 data retail underscore DB products. Okay, and then you can validate it by running products count and hit enter. There are 1344 records, and then to preview we can say for I in products dot takeoff 10 print of I. You can see the 10 records. So the first element is, the first attribute is product ID, second attribute is product category ID, third attribute is product name, and then I think fourth attribute is description, fifth attribute is the product price. And I want to see all the product prices in ascending order or descending order. So to get product prices in ascending or descending order, we have to use product price as key. Sorry, we can extract the product price, and then we can just apply a function called sort, and the data will be sorted. So in this case, what I'm trying to do is I'm trying to apply map function to extract the product price by using the lambda functionality. Okay, rec, and here I want to get rec dot split, comma is delimiter, and I want 0, 1, 2, 3, 4. So here we have to use subscript using square brackets. Okay, so this will get us the uh, prices. It will extract the prices. So here products prices equal to this one, and by default, as we are trying to process the string, even though the value is float, it will internally feel that it's a string, and the results will be incorrect if we try to sort directly using the values that are extracted here, because the data type will be string. String sorting on the values will give incorrect results. So here we have to apply typecasting, and the way you can do the typecasting is for integer it is int, for float it is float, etc. Whereas in Spark, what you have to do is you have to say like this, to float on the value or on the object. Here we have to apply the float function like this, and we have to pass the relevant record as parameter. Okay, and hit enter. Again we can see the preview of the data for I in products prices takeoff 10 print of I. You can see now the prices are extracted in the form of float. Okay, if I don't cast it, you will see U here, and it will actually represent it as string. Now we want to sort. So the way you can sort is for I in products prices or prices. Okay, sort print of I. 1 minute. I think what I have to do is I have to apply sort on product prices. Let me get the function name. Unfortunately, in Pyspark, it will not autofill as in Scala. That's one caveat. You have to go to the Python documentation to get the sort function. Sort is actually Python-based function. Yeah, we have to use sorted. 1 minute. Let me go through the documentation. So Spark 1.6.2 programming guide. So here by default it will choose Scala. Everywhere it will show the Scala based documentation. If you want to go to Python, you can click on Python anywhere and everything will be refreshed automatically to Python. Here also we have to go to transformations and actions. And as part of actions, we have reduce, collect, count, first take sample, take ordered, etc. So there is no sort action here. So we can't use sort directly. Rather, what we have to do is, if we have to sort, we have to use take ordered. Even in Scala, we have to use take order only. We cannot apply functions such as sort. There is no function like sort in it. Okay. And now we can actually say for I in products prices take ordered, and take ordered takes one parameter such as n, which will only fetch so many number of records. So if I say take ordered of 5, which means that it will only return top 5 records. Let me show you. Print of 5 here and hit enter. You can see it's in ascending order. That's why it is actually showing all zeros first. Okay, you can actually change the ordering. Let me see, I have the code snippet already. Here, let me use it as a reference. So if you want to get it in ascending order, descending order, you have to apply the logic like this. Okay. So for the same thing, what you have to do is the second parameter should be lambda function. And in this case, I want to sort it in descending order. Okay. So this x is nothing but this value for each iteration. Okay. And it is sorting in the descending order if you use minus x instead of x. Okay, now you can see the values are in descending order. So there is another function called top. Okay, let me see. Okay, top is again Scala based function. So to sort the data and get top 5 records, you have to use take order directly. You can do that. You can, but you have to pass that first parameter, how many you want to display. Only then it will work. So now if you want to sort the entire data based on price, okay, take ordered can be used, but it will only give the top 5 records. In this case, we are only getting the price and we are actually getting the top 5 prices. But typically we want to see what other attributes of the top 5 priced products, right? So in that case, what you have to do is, let me do it in the Sublime text. Okay, now the products is red and then you can say products take ordered directly. Okay, and I want to get 5 products. Okay, and then I want to write a lambda function. In this case, each record is the complete line. Okay, and I want to get products and all the product details, top n priced product details based on price. So we have to use the lambda function to define the sorting order. So earlier we have only price, it's pretty straightforward, we just say minus x. Here it is not the case. We have the entire record and we have to pass through it, extract the product price, and based on that we want to sort. So what we have to do is lambda x, and here we have to apply the split function. So comma is the delimiter, and we want to use the fifth field, so we can actually access it using 4. Subscript can be defined in the form of square brackets in Python, and then we are defining minus as the negation so that we can get the results in descending order. And then we can say for I in, because it's take ordered is an action, we don't need to use collect or take further. Okay, we just have to say print of I. Okay, there is one bad value due to which, okay, I know the problem. Here we have to convert it into float. We are trying to apply minus on a string, which is not correct. Hence we have to convert into float and then negate it to get the results in the descending order. One more bracket is missing here. Yeah. Now you can see you not only get the price, but also we get the rest of the values. The complete record is displayed. Okay, the main thing, the main logic which drives that is this lambda function. So take ordered is a very powerful function where you can get the data in sorted fashion, and then you can actually define the custom logic to sort the data in the way you want. In this case, we are trying to get top 5 priced products based on price, and price is the 5th element in the record. Hence we are giving the logic here how to sort the data. Okay, and you can see that 1999.99 is the top priced product, then 1799, and so on up to 1099. Okay, so this is how you can use the take ordered function to globally sort the data and get the results the way you want. And also there is another function called sort by key. Even though it says sort by key, typically it is used to sort the data globally by key. Okay, so there is an alternative way to get the same thing here. Instead of using take ordered, we can also use function called sort by key to globally sort the data. Take ordered limitation is if you want top n products, you can use take ordered. But if you want to do the global sorting, you have to use sort by key only. So here you can achieve that by saying for I in products dot map. So first we need to identify the key on which the data needs to be sorted, and lambda rec, and we want to create a tuple here, rec dot split comma 4. We have to apply the float. Okay, and then the tuple have the second element as record. So the key is in the tuple, the key is the float, sorry, the product price, and the value is the record. Now, as the product price is key, we can apply sort by key function. Here you should not indent. If you try to indent, it will consider it in a scope and it will fail. So that's the drawback with Python. If you want to write a line of code in multiple lines, you should not indent at all. Okay. So sort by key will actually sort the data by key, and it's a transformation. Hence, we have to use collect or take to preview the data, and then print of I. Okay. So here map function is extracting the product price as key and the enter record as value, and based on key we are trying to sort. Even though we say sort by key, it is actually used to do the global sorting only, but based on a key. That's why they call it a sort by key. Okay, we cannot do this. What I have to do is I have to, I think, use this backslash to write it in multiple lines. Yeah, so you have to use backslash as you do in shell script, and then hit enter. Now we can see the data. Data came in ascending order. So this sort by key also takes parameters such as true or false. By default it is true, which will sort the data in ascending order. You can also pass false like this, and the data will be sorted in descending order. Okay, now you can see that last one is 0. Earlier the last one is 19, 99, 99 because it is sorted in ascending order. So this is how you can achieve the total sorting, either by using sort by key if you want to sort the data by a key, or if you want to get top end products or top end products on the entire data set, you can use take ordered. Okay, so that covers the global sorting and ranking. Sort by key and take ordered are the key transformations or actions to achieve that. Now we will see by key transformations and actions. So when it comes to by key transformations and actions, by key sorting and ranking, not by key transformations and actions, we need to understand the transformation to do by key sorting and ranking. For that, we have to use group by key only. There is no other alternative. So using group by key, you can do anything. You can do the aggregations the way we have done for reduce by key or aggregate by key, but it does not use combiner. So in most of the aggregations, we don't use group by key. There are some exceptional cases where there won't be much benefit by using combiner. We can consider using group by key, and group by key can outperform the reduce by key or aggregate by key. On top of that, we also can use group by key for sorting and ranking based on a particular key. I will give some real world scenarios where it comes handy. So you have a retail industry, or you take the example of a major retail store where they have stores in each and every state, and you want to get top 3 stores by revenue in each state. That means you have to get a ranking of the stores in each and every state. So the key will be the state, and within the state you have to get the ranking. Okay, so for that purpose you have to use group by key only. We will define state as key, so all the data with respect to a particular state will be grouped. Okay, and then you can do whatever operations you want on them to get sorting or ranking within that group. We will understand how we can do it programmatically in a moment. So for this, what we'll do is, so if you look into the products data, we have product ID and we have product category ID. Okay, here I'm trying to read the categories data set, and I will explain what each category is all about, and then we will try to get ranking or sorting within each product category, as part of developing the Pyspark program for sorting and ranking. Okay, so here I am creating a new RDD called categories sc.text file. Okay, this line for in categories dot collect. There are not many categories, so I am directly using collect, print of I, and hit enter. You can see there are 1 to 58. So there are, sorry, yeah, 1 to 58. There are 58 categories, and products, there are 1344 products. So these 1344 products are divided into those 58 categories, and approximately each one have 30 products in each category. And if you want to get top 3 products in each category, we have to use group by key function. Okay, if you want, you can do the join also between products and categories and get the category name. But in this case, I will just use the category ID. I will not do the join. Joins are already covered, and it's very straightforward. You just have to extract the key between the two tables, the common key between the two tables, and then use the join operation. It's very straightforward. Hence, I will not be getting into that. I will directly get into the group by key only. Okay. So now we will primarily focus on products, and we can say group by key to group by a key. And to group by a key, we have to use map function. First, we have to apply the map function. So let me use the sublime text only here. So first, we need to read the data like this, and then we have to apply map. And there is one bad record in the data set. I think that is 658 or 685. I made a note here. Let me see. I think it's in this only, or probably in this sorting and ranking by key. So 6. Somewhere I have that information on the bad record, probably in the filter. Let me see. 658 products. Okay, I have it in my GitHub code. $685. So let me get the value of that 685. Or I might have already deleted. Let me see. So for in products.filter lambda rec integer of rec dot split comma, I want to get the first element equal to 685. Print of I. I have to use collect here. So there is no such record. So we are good to go. We can directly use this one. If you, I think I have deleted and then I have created the data set in the GitHub account. So we are good to go. If you directly use Cloudera Quick Start VM, if you get data from MySQL into HDFS, this record with 685 can cause some issue. Just keep that in mind. Okay. You can use filter and filter that out. Anyway, so now we can. So what we are trying to do is we are trying to group by the key, and the key is product category. So what we have to do is in products map we have to apply map function like this, and then in the lambda function we have to create a tuple. Okay, comma is the delimiter, and the key is product category ID, not product ID. Okay, because we want to group by product category ID. So here we have to say int because it is of type int. Always, if your key is of numeric type, it's best practice to cast it into that numeric type, because all the operations such as aggregations, joins, etc., is much faster on numeric types compared to string type. Okay, hence it's always recommended to cast it like this. Okay, and then let me see where the so there is one extra here. Yeah, and then the second element in the tuple is the record itself. So we are trying to group all the records based on the product category ID. Okay, now let us run this one. Okay, so what I have to do is, why it is failing? Okay, I have to create the tuple here. I didn't create the tuple, that's why it is failing. Now it will work. Okay, now you got the tuple. The first element is the product category ID, second element is the record. You can preview by using for loop for I in products map dot take of 10 print of I and hit enter. You can see the key here and the value, the product details itself. Now we want to apply the group by key on this. So products group by category products map dot group by key. We don't need to do we don't need to apply any transformation yet. We will do that very soon. So you can copy this one and then for I in take off 10. It is very important to do this. That way you will understand how the data is represented after each and every step. Print of I and hit enter. Now you can see that for each category ID, the value is nothing but a iterable, which means kind of array or list. Okay, and also you can actually do the count on this one. It should be close to 58. 55. So there are 3 product categories where there are no products associated within the products table, which is quite common, quite normal. So now you can see that after grouping by key, we got product category ID, and from each product category ID we are getting all the products associated with category ID in a array or list. That's why it is saying it's an object which is iterable. Okay, now using this object which is iterable, we can do whatever we want. We can, if it is all numeric values and if you want to get the sum by a particular key, you can apply sum function If you want to sort the data, you can apply sort. If you want to rank, you can apply the ranking function. First, we will see the sorting, and then we will see the ranking. Probably tomorrow we will see the ranking. You can go here, click on sorting and ranking using Pyspark by key. And if you just want to sort the data within each product category ID, you can apply on the group function, you can apply the map function. After group by, you can apply the map function. So let me do that now. So for in, instead of using for in, let me products sorted by category. So this is new variable which we are trying to create. So we are using product category, product group by category. I am writing in multiple lines. Okay. Here we have to apply the map function. As part of the map function, we will access, we will pass each of the record of this RDD as the value. So this record represents each and every record. And what is each and every record? It is nothing but this one, which have the category ID as key, and all the values under that category, or all the products under that category is in the array or list. Okay. So here, here what we are trying to do is we are trying to sort the data from within each key. Okay, so I don't want to get the key. So after this map function, so I am not creating the tuple. I just want to get the data in sorted fashion. So here I can say sorted like this. The logic is here. The whole logic. I can copy paste. I will explain what I am trying to do. So sorted is a Spark based function which can apply sorting on an array. For example, if you have array which is 1, 0, 3, 2, 5, you can say sorted array. The data will be sorted. So in each record is giving some iterable like this. It could be list or array which can be sorted, which can be iterated, and we can apply sorted function on all those lists, arrays, etc. Okay. So we are getting, but instead of just getting the plain values like this, we are getting our records from the product table, which have a product ID, product category ID, and one of them is product price. And in our case, I want to sort by product price. Okay. So what I want to sort? I want to sort the array within the record. The first element is the key, which is product category ID, which is represented as rec of 0, and rec of 1 is nothing but an array. So we are trying to sort an array. How we are trying to sort? So this is the logic to sort. Okay. Here we are passing a lambda function to the second parameter for the sorted. So for sorted, first parameter is what we want to sort. If we just use sorted, and if we ignore this logic, it will sort it will sort by the products based on the alphanumeric values we have in each and every record. But that is not how we want to sort. We want to sort on the product price. Okay. So what we are trying to do is we have an array like this. Some product category, product ID, product category ID, and then the price such as 10.0. Let's say there are 3 elements, and then second element in the array is another string, which is something like this. And if I have to sort these things, what I have to do? I have to use sorted and array. I want to sort the array, And then here sorted also takes, if I just do sorted and hit enter, you can see this is the minimum uh, based on the entire value. 1 comma 2 comma is smaller than 1 comma 3 comma, so it has sorted in ascending order based on the characteristic of each and every record, which is alphanumeric in this case. But I want to sort by the third one. So what I have to do, I have to apply the sort function, and then I have to apply the logic to sort. So the key is the parameter which we want to override to sort in a particular order, to sort in a custom order. Okay, here it takes the lambda function. So lambda, in lambda we so the parameter which we are passing is nothing but the record, and we have to define the logic to process that record and define the sorting order. So here we have to split. First we have to apply the float function, x dot split comma third parameter is represented by 2. Okay, yeah, that's it. And then we have to close another bracket and hit enter. Now you can see that data is sorted based on the price. So the same thing we are doing on the um, on our RDD, but RDD is a tuple. So as it is tuple, the parameter which we are passing is also a tuple, but we are interested only in the value of the tuple, not on the key, which is product category ID. And then the array will have elements which have product ID, product category ID, product price, etc., which is the fifth element. And here we are defining the logic, and this logic will make sure that data is sorted in ascending order. If you sort it in descending order, you have to use minus here. Then the data will be sorted in descending order on product price. And now if you run this logic, there is some issue with the syntax. Let me see. Yeah, there is one additional bracket. Let me validate it here. Yeah, now it should work. Okay, now you can say for I in product sorted by category dot select print of I and hit enter. Now you can see that data is sorted within each list, but the values are displayed in the form of array itself. So you can see for product category ID 59, the least priced product, the least price is $100, and this is the product Nike men's home game jersey Cleveland Browns, and you can sorry, this is the highest priced because we have used minus over there, so it is the highest priced, and the least price is $28, which is Cleveland Browns Johnny football. Okay, so this is the list, and if you want to flatten it out, what you have to do is you can actually apply the flat map function here. Or I think let me validate this one. I'm not 100% sure whether it will work. Yeah, you can just use the flat map to flatten it out. So the map function actually sorted within the function, and each array is written as one record, whereas flat map actually flattened out all the data after the data is sorted, and then you can see in as a different record. Okay, you can see all the 59s are grouped. Top price product in category 59 is of price $100, and the minimum one is $28. So the results are fine. So this is how you can do the by key sorting by using group by key function. So group by key is very important and very powerful You can apply many types of transformations on group by key, such as sorting, ranking, many other things. Only thing is, to use group by key effectively, you also need to understand the underlying programming language constructs, such as sorted. In this case, sorted is not Pyspark or Spark API. It's a Python-based API. From the certification point of view, I hope they will not ask the questions up to this level, especially for CCS Spark and Hadoop developer. But if you go to HDP-CD Spark, which is primarily on one programming language and Spark, they might go to up to this level. So if it depends upon which certification you want to give, and you need to understand or you have to judge or make certain assumptions up to what difficulty level they might go. If you are planning to give HDP-CD Spark, and if you want to explore a programming language thoroughly, then you have to understand all these underlying programming language constructs also. At the time of working on job, this is very, very important. For certifications, this might not be that important, but on job, it is very, very important to understand all these underlying programming language APIs also, especially on collections, to write more sophisticated Spark-based applications using underlying programming language such as Scala, Python, etc. Okay, so we are done with global sorting and ranking, and also by key sorting. Now the next thing is by key ranking. We will actually do it tomorrow, but there are certain things which you need to keep in mind to do group by ranking. Okay, so far we are implementing the logic inline to the lambda function like this. Okay, at times we want to create a typical function and we want to invoke that, and you need to understand how to create the functions, whether it is Scala or Python, and how to invoke them as part of your Spark based APIs. It is another important thing. Even in CCS Spark and Hadoop developer, they might put this logic in a regular function and they might ask you to invoke that function. So you should know how to invoke that function. Okay, so we'll use the same example. So instead of using inline function like this, we will actually create a regular function and then we will invoke that function. Okay, again, I'm not very expert in Spark, so I'm using already existing code snippets for my reference. So this is how you typically define a function in Python. So it starts with def. You have to give the function name and you have to give the parameters. Nowhere you will tell the data type of the parameters, and also you don't need to specify the return types in Python. Okay, so here what we'll do is we'll create a function, regular function, def group by sorting, that is the function name, and it takes one parameter, which is nothing but the one which will be passed as part of the lambda function. And this is the end of the function specification. And here the scope starts with the indentation. So all the lines of the code should be a part of the indentation itself. Okay, so that it comes under the same scope. Even the return also should be within the scope of indentation. We will see. Okay, here what we'll do is we'll directly create a variable and implement that logic in that variable. So let's say sorted data equal to this one. So we'll pass the entire record as the enter RDD as the parameter here. Sorry, enter record as the parameter here as part of the map or flat map function, and the enter record have the key which is product category ID and the value which is collection. Hence we have to read the collection only. So whatever logic we have done here, we are specifying here. So when it comes to if you want to invoke it in a flat map, you have to use logic similar to this. Okay, you have to say return So for y in x is nothing but the loop. So in place of x, we have to give the variable name here, which is this one. Y is just defined here. So we are trying to return y for within each iteration in the flat map. Okay. Sorry, the return is actually returning one record at a time for the flat map. If you are trying to invoke this one in the map function, you can directly return sorted data. So we will do both. First, we will return from the we will use the map function. So in the map function, we will just return sorted data. Okay, and once you create the function, what you have to do is we have to specify map lambda rec. Okay, and we have to invoke this function. This is how you can actually invoke the functions. Okay, you just have to create the function like this. So you can copy paste this one. Now the function is created. Now you can run this one. Okay, for in. So indentation is important here. If you use this directly here, means if you copy paste this one, it might fail here because this is not indented in this. So it's a typo in when I actually copy pasted the code here. I will cover this function tomorrow. It's a little bit more complicated function. I will explain the problem statement and go through it tomorrow. As of today, we will only see how to create the function and how to invoke it. Okay, we already invoked it and now we have to validate. For in product sorted by category dot select print of I. Now you can see the data is returned the same way as we have applied the map function without without invoking this function. So when we actually invoked this one with map function, we got the same results. So your function logic will change what type of API you are using to invoke that function. When it comes to map, we have to return the collection. We cannot return elements in the collection. Okay. So if you use flat map, the logic will change. As I have explained earlier, we have to return y for y in sorted data. Again, this is nothing but a Python construct. For y in sorted data is the for loop, and you can read each element like this to return as part of the Python. Okay. Now you can actually recreate the function, and then here you have to say flat map, copy paste this one, and then you can use for I in. Now you get the data flattened out, and depending upon the type of API you are using, you need to understand how you should write the function, and you have to implement the function like this. So it could be possible in CCA also. They can give function logic also, and they might ask you to invoke that function as part of map function or flat map function. So it will be good idea to explore even for the certification. For the job, to write complex Spark based applications, you need to understand how to modularize, and you need to understand the underlying programming constructs to successfully implement the applications effectively. That being said, I will take few questions here, and then we will start tomorrow on the same topic on Pyspark, which is reading data, ranking. So instead of sorting, we will be seeing how to rank the data based on particular key. Okay. Sure. So if you want to understand how to write a function and invoking it in a Scala application, it's pretty straightforward. I will do that. I will explain. So I already have this one. So we will be using the same thing. I mean, yeah, let me see. Let me copy and paste it over here. Okay. Okay. We have to change the name. So it's not just about function when it comes to Scala. You have to understand object-oriented concepts also, which I will not be covering at this time. I will conduct a workshop very soon on Scala. I am preparing the material for it, and as part of that workshop, I will show how to do most of the things that are relevant for Spark from Scala perspective. So the way you create the function is same as this one, def main. Def main is itself is a function, a main function. Okay, if you want to add one more function instead of implementing the logic um, as part of the, let's say, I will take very simple example. Yeah, we can take this one. Okay, here we are applying the filter logic, right? So we'll create a function, and this filter logic has to return true or false. Okay, by the end of it, we have, or I will only use this one. Okay, and this function is just incrementing something and returning it. It's not doing anything else. So what I have to do is def increment accumulator. That is the function name, because I am trying to increment the accumulator um, here. Okay, and what is the parameter it takes? We have to we are trying to pass the record, and this record is of type string, because each element is string in orders, RDD, after reading the data here. So it is nothing but of type string. So we have to give the parameter name. We will give it as record only, and the data type is string. Okay, and then we will be using the logic. And let me see, it is complaining for something. Okay, here I have to pass this also as the parameter, because this is out of the scope of the main function. Hence, we have to pass this one also parameter, and this one is nothing but of type integer. Okay, is not a member of int. Let me see. Okay, it's accumulator of int. Okay. I think I cannot, I should be able to pass it. I just need to understand how to pass it. So it is of type accumulator of int. Probably this could be another limitation. Okay, anyway, I will show you the, no, I cannot put the def. We cannot put the def here. Def is here, which is already there. So anyway, I have the code here. So I will explain you where you can actually uh, look for the same. So you can actually go to sorting and ranking using Scala by key. Okay, it's the same use case on products which we have seen. And after tomorrow's class, we will understand. So the same logic I will try to explain even with Scala, how we can do it in Scala. Okay. So what we will do is, this in global sorting, we just sorted the data. But tomorrow we will get the ranking, and there are two types of ranking. One is dense ranking, and the other one is sparse ranking. In case of sparse ranking, if there are duplicates, let's say you want to get top 5 products. If you have duplicates, all the top 5 products might be with the same price. Okay, if you want to get top 5 or top n priced products, which means that I want to get all the products which falls in the category of top n prices. So if you give 5, I want to get all the products which fall in the category of top 5 prices. At times it could be more than 5, and if I want to get all of them, it's called as dense ranking. So we will take the dense ranking as the use case for tomorrow, and we will see how to write the functions and invoke those functions as part of the Spark APIs. We will do it in both Python as well as Scala tomorrow. Okay. Any other question? So tomorrow's class is very important because we will be we'll be actually writing a little bit complex Python or Scala based code to achieve, and it will give you some taste of how the collections work. I will also give overview about a little bit overview about collections, and I will try to use those as part of the explaining the logic. And you have to focus on this, and this is not very important for the certifications. In certifications, they don't go up to this level, but for day-to-day job, you need to understand the collections irrespective of the programming language you try to use, and you should be able to use underlying programming APIs to effectively write the programs with minimum number of lines of code and with best performance. So you have to understand many APIs of the underlying programming language based upon your use case, and tomorrow we will see a perfect use case for that. Okay. Any other question? I can take a couple of more questions. If you are asking any question, just type that you are asking a question and you can ask a question. If I didn't see any questions in 10 seconds or 15 seconds, I will wrap up for today. Okay, then I think you don't have any questions, so we will catch up tomorrow. Tomorrow class is very important. Make sure you attend the class to understand not only the Spark APIs but also the underlying programming constructs to write more sophisticated applications in Spark. That being said, thank you very much. Bye.